Hello everyone, I am Dme Cv from Mechanical second year. My concept video presentation topic is design considerations for a casting. Design considerations for casting. Successful casting practice requires the proper control of a large number of variables. Like the casting is the main, or we can say that bulk producing industrial process, and the design of a casting depends on the flow of the molten metal, mold cavities, gating systems, rate of cooling, and gases evolved from the casting, melt, etc. Casting is a manufacturing process in which a liquid material is usually poured into a mold which contains a hollow cavity of desired shape and then allowed to solidify. The solidified part is also known as casting, which is ejected or broken out of the mold to complete the process. Casting materials are usually metals or various cold setting materials that cure after mixing two or more components together. Example: concrete, plaster, and clay. Casting is most often used for making complex shapes that would be otherwise difficult or uneconomical to make by other methods like body of the engine and all the solid parts, etc. First, casting depends on these consideration properties like design the part so that shape is cast easily, select a casting process and material suitable for the part of size, mechanical properties, etc. Look at the parting line of the mold in the mold. Look at the design and the gates. To allow uniform feeding of the mold cavity with molten metal, select an appropriate on the geometry of the system. Look at the mold features such as sprue, screens and risers as appropriate. Make sure proper controls and good practices are in place. First one, in the considerations comes is corners, angles and section thickness. Avoid using sharp corners. Sharp corners, we should give some fillet to the corners, and angles act as stress raisers and may cause cracking and tearing during solidification. Use fillets with radii ranging from 3 to 25 mm. It will release in smooth flow and smooth absorption of heat and cooling uniformly and rapidly. Here in the diagram part in A, the first part is poor in design because the stress comes into action. The stress concentration will be more in the first part than the part below it, and the second part, the first part is also same, the stress concentration and the heat transfer to the atmosphere. Section changes in casting should be blend smoothly into each other. Location of the largest circle that can be inscribed in a particular region is critical so far as shrinkage cavities are concerned. Because the cooling rate in regions with large circles is lower, they are called hot spots. These regions can develop shrinkage cavities. Cavities at hot spots can be eliminated by using small cores. It is important to maintain uniform cross sections and wall thickness throughout the casting as much as possible to avoid or minimize linkage cavities. Here, the deep explanation of the design of corners, joints, thickness, and shapes. Flat areas. Large flat areas should be avoided since they may wrap during cooling because of temperature gradients, or they develop poor surface finish because of uneven flow of metal during pouring. To resolve this, one can break up flat surfaces with staggered ribs. Pattern making dimensions also should allow for shrinkage of metal during solidification and cooling. Allowances for shrinkage known as pattern maker shrinkage allowances usually range from about 10 to 20 mm per meter. Draft. A small draft or taper typically is provided in sand mold pattern to enable removal of pattern without damaging the mold. Drafts generally range from 5 to 15 mm per meter depending on quality of the pattern. Draft angles are usually range from 0.5 degrees to 2 degrees maximum. Dimensional tolerances. The tolerances should be as wide as possible within limits of good part performance. Otherwise, the cost of the casting increases. In commercial practices, tolerances are usually in the range of 0.8 mm plus or minus for small castings. For large castings, tolerances may be as much as 6 mm greater or lesser. Letterings and markings on a casting. It is common to practice to include some of the part identification such as naming or logos, indications, etc. in casting. These features can be sunk into the casting or protrude from the surface. Machining and finishing operations. These are the final operations of the casting should be taken into account. For example, a hole to be drilled should be on a flat surface, not a curved one. Better yet, should incorporate a small dimple as a steering point. Features to be used for clamping mesh machining. Some defects are common to any and all processes. These defects are illustrated in the first figure, briefly described in the following. Misruns. A misrun is a casting that solidified before completely filling the mold cavity. Typical causes include fluidity of the molten metal and pouring temperature must be low, might be low, or pouring is done too slowly, or the cross section of the mold cavity is too thin. Cold set. A cold set occurs when two portions of the metal flow together, but there is a lack of fusion between them due to premature freezing. It causes a similar to those of misruns. Shrinkage cavity. This defection is a deflection in the surface or an internal void in the casting caused by solidification or an internal shrinkage that restricts amounts of molten metal available in the last region to freeze. It often occurs near the top of the casting, in which case it is referred to as a pipe. The problem can often be solved by a proper riser design. Microporosity, which refers to a network of small voids distributed throughout the casting caused by localized solidification shrinkage. The defect is usually associated with alloys because of different freezing points of the metals mix. Hot tearing. The defect is manifested as a separation of metal at a point of high tensile stress caused by metal's inability to shrink naturally. In permanent mold processes, removing the part of the mold immediately after freezing reduces hot tearing. And that's all for my presentation on design recommendations for a casting. Thank you.